I'm Shan Smith with Good Sense Automation. Good Sense Automation is a systems integrator located in Greenville, South Carolina. Our specialties are robotics, vision, and PLCs. So the next time you have a need, please keep us in mind. This is a quick tutorial on PLC scan time and how scan times work. So bear with me for a minute and I'm going to share my screen. So what is PLC scan time? PLC scan time, or you may hear the term cyclic I/O. That means that the scan time continuously cycles repeatedly or cycles all the time. So with your scan time, kind of all over the place right now, with the scan time, it's right here. We read the inputs, analog and digital. We execute the program code. We write to outputs. We handle communications and diagnostics. And that is PLC cycle time. This happens continuously in every PLC. And your nominal PLC cycle time is anywhere from 0 to 50 milliseconds. Depends on the PLC. We're going to talk about some of those factors, but again, your cycle time is cyclic. It's cyclic I/O. You're continuously reading your inputs, executing the program, right into your outputs. So a few topics we're going to cover is an introduction to PLC cycle time. An introduction to PLC cycle time. What is it? What factors affect PLC cycle time? How do you calculate cycle time? It's a nice to know, not a need to know. As far as PLC cycle time, normally you can look at your controller, look at the memory, look at your I/O, analog and digital, and you can calculate that. So, it's a nice to know, not a need to know. How do you optimize cycle time? And then, of course, your applications, and then we will conclude. So PLC cycle time refers to the time it takes for a program to complete its full cycle of operations, which include reading inputs, executing logic, updating outputs. And an important parameter to consider is how many I/O you're going to have. So again, your cycle time is directly affected by program size. So when you look at how you design your program, how you set it up, you can be the tortoise or the hare, which means if you have a lot of elements you don't need, and this is the reason we use program calls. We have a main in most control systems, and then you call the logic that you need in that time instead of continuously executing code that does not need to be read in that time. So the time it takes for a PLC to complete one full cycle of its operations, including reading inputs, executing logic, and updating outputs. This is important. So again, it's that same symbol we looked at in the beginning for PLC cycle time. So what factors affect our cycle time? Factors that affect our cycle time are the number of I/O, the size of the controller, which means a lot of times in I'll say colloquial automation terms is how much horsepower does it have? How much memory does it have? How much RAM does it have? And can you add in additional memory to that controller? How you write your code? Other factors that include all your communication protocols. How much communication do you have? The size of the program, and the efficiency of your code. All are factors that affect your cycle time. And this is the reason a lot of people like text-based logic versus graphical-based logic, because all those graphics do consume and eat up a lot of memory in your cycle time. And again, we mentioned a few minutes ago, like calculating cycle time, you can do it. But again, if you know the controller, you know your I/O, it's going to be the best way to do it, but here you go. To calculate the cycle time of a PLC, you need to know the execution time of each instruction in the program, total number of instructions, and once you have this information, you can use this simple formula to calculate cycle time. Hey, know your controller, know the product you're working with, and if you know that product, you can have a very good approximation of how much time, how much horsepower you're going to need for that controller. So this can be, maybe it's overkill, okay? All right, how can I optimize the cycle time of my controller? There are several strategies you can use to optimize the cycle time of a PLC. Simplify your logic, reduce the number of I/O, using a faster processor. That's going back to have the process with really great horsepower. Other methods include optimizing communication protocols, reducing program memory usage, and writing efficient program code. So that's how you optimize. Applications, of course. So if you have a robot cell, you're gonna have a PLC, you're gonna have maybe some type of tool in the robot, you're gonna have safety. All of these are applications of cycle time. All of these will take CPU memory, and all of these elements will affect cycle time. So PLC cycle time is an important parameter in many industrial automation applications, including process control, robotics. By optimizing the cycle time of a PLC, you can improve the efficiency and accuracy of the system, leading to increased productivity and reduced downtime. So again, cycle time is that cyclic I/O, executing code, and you really want to think about using about maybe 85% of the capacity of your controller. Cycle time is a crucial parameter to consider when designing and implementing a control system. By understanding the factors affecting cycle time, calculating the accuracy, and optimizing your code, you can reduce the cycle time. So again, cycle time is cyclic, it's always happening, and it's going to be based on horsepower, number of I/O, all those factors. This has been Shane Smith with a quick tutorial on cycle time. Have a good day.